Hey guys, a friend of mine told me about this Advent of Code event that's going on. So it's essentially some coding challenges that are going to be coming out every single day throughout the Advent calendar. I don't know much about the Advent calendar, but coding challenges are fun. So he pointed me to this website where I just created an account. So essentially, what's going on is every single day they're going to give us one of these challenges, and you get some points when you submit them. So I'm just going to read through this real quick so you guys know what's going on, and then we're going to do this first puzzle here that they proposed. So I haven't done this yet. I haven't solved it. I sort of just peeked, and I kind of have an idea of what they're asking, but we'll read through it again. So after saving Christmas 5 years in a row, you've decided to take a vacation at a nice resort on a tropical island. Surely Christmas will go on without you. The tropical island has its own currency and is entirely cash only. The gold coins used here have a little picture of a starfish. The locals just call them stars. None of the currency exchangers seem to have heard of them, but somehow you'll need to find 50 of these coins by the time you arrive so you can pay the deposit on your room. So you're a bit of a shitty traveler. To save your vacation, you need to get all 50 stars by December 25th. Collect stars by solving puzzles. 2 puzzles will be made available on each day in the Advent calendar. The second puzzle is unlocked when you complete the first. Each puzzle grants 1 star. Okay, so every day we get 2 puzzles and we get 1 star per puzzle. Before you leave, the elves in accounting just need you to fix your expense report, your puzzle input. Apparently something isn't quite adding up. Specifically, they need you to find the 2 entries that sum up to 2020 and then multiply those 2 numbers together. For example, suppose your expense report contained the following. So some list of numbers. In the list, the 2 entries that sum to 2020 are 1721 and 299. Multiplying them together produces 1721 times 299. Okay, so then that gives us the result. Of course, your expense report is much larger. Find the 2 entries that sum to 2020. What do you get if you multiply them together? So, and then there's a little space for our answer. Okay, so they're giving us our own input. So we're gonna need to take these numbers and plug them into our program. So, oops, that was stupid. Okay, so yeah, so one way to do this is to take this, save it as a text file, read it line by line, and then convert each string into an integer, but I'm too lazy to do that, so I'm gonna use some Vim magic and just turn this into an array. So let's paste that in here. And essentially all we need to do is just wrap this with braces and put a comma at the end of each line so that it separates each element. So let's do that with, there's 200 lines. So in Vim, if you type a number and then a command, it'll execute that command that many lines. So you can just do 200 and then I don't even know what the stuff means. I've just looked up how to do stuff like that in on Stack Overflow in the past, trying to figure out how to do certain things. But essentially we just told it to run a command and then execute it another 199 times there. So anyways, it's gonna run it. So by the way, I'm running Emacs with what's called evil mode, which essentially gives Vim key bindings to Emacs. So you get all the niceties of Emacs, but you get the reduced carpal tunnel of Vim. So anyways, let's do this. Yeah, okay, good. And we're just gonna take this last one out. And actually let's do, we're gonna call it int numbers and then equals and initialize it like this. And then, okay, so that should give us an array. Okay, so now let's put a little main program. Okay, we got that. And let's get some IOStream going so we can actually print stuff out. You can see out, okay, and I'm just gonna do it up here. I don't care. I normally don't do this and put like namespace, using namespace, just kind of globally like that, but whatever, I don't care. We're solving a problem, I'm not trying to do a maintainable project. Okay, so now let's quickly just loop through that array just to prove that our input is good, because as trivial as it might seem, sometimes you get stuck solving problems and then you realize, oh, why isn't this working? And then you go back and you're like, I didn't even check if my input is correct. So I'm gonna do that just to make sure. Let's loop through our numbers. Count and L. Okay. Now I forgot to mention, I've already set up a project here, just a CMake project that it has my CMake lists here. Let me just open that up, which is essentially just a very basic CMake project. I'm just using it so I can get my compile commands and just quick compilation going. So I'm not going to bother you with the details of CMake and blah blah blah, but just know that the way this is working is I have this folder structure here, and then inside there, my source folder, I'll have just day one. This is actually should be called day 1A and day 1B if there's 2 puzzles per day, but I'm gonna rename that later if I have to. So yeah, so just so you know, and I'll be compiling it right through Emacs, and let's just hit compile. Okay, so that built, no errors. So let's go in our build directory and see what we got here. We got day 1. So when I run this, I should see that list of numbers, and I do. Let's go back to our file. 1948, 1894, boom. Okay, so our input works. Now, the most basic way to solve this is just a nested loop. So that's really slow. And one could argue, if we're just doing this kind of just to get a result and solve this problem, why not just do the nested loop solution? It's only going to run once. It's not like this code is on some critical path somewhere, and we need to make sure that it works with any number of inputs and blah, 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 and it's going to run consistently every day. You know, it's just, we're just trying to solve this problem. And if that's all you're doing, you're just writing a program to solve a problem, by all means, a nested loop, n squared runtime, which is slow and it's a crappy runtime. Who cares? You're only going to run it once. Now, if you had millions of inputs here, even still, you know, you could just do it and go get some coffee. So I want to solve it the slow way first and prove that it works, and then maybe we'll take on a challenge to solve it the quick way if I feel like it. But I do actually want to solve it that way, because part of this is challenging yourself. And I mean, you could brute force it and solve it with the nested loop, but you know, the challenge and the fun in these is kind of figuring out some clever way, perhaps, if you know, if this algorithm was to run on some critical path somewhere in your code, or hot path, not a critical path, you know, you'd want it to be optimized. You don't want to just loop and then for every iteration loop a full, right? Like that's n squared is not a good runtime to have on an algorithm. Okay, so anyways, let's solve it, make sure it's correct, and then we'll see, maybe we'll solve it in a quick way and see how that works out, and then compare the results, obviously. But let's do it correctly. Even if it's slow, let's try and do it correctly first. Make sure we get the right result, and then we can use that result as our baseline to maybe do an optimal solution, like a quick one. Okay, so let's call our solution here. Have a function called slow, and that'll loop through these numbers and try and find the solution. And we can do a quick solution too. So for int I equals 0, I is less than. One thing I don't like doing is hard coding array bounds. I wonder, can I just do let's say vector int numbers equals, if I do that, let's just quickly make sure again. I'm just neurotic with stuff like this. Yeah, that's fine. It's complaining because slow is not returning a value. Doesn't matter. Okay, good. So I just wanted to do that because if I initialize a vector like this statically, then we get like an array doesn't have a size property. Obviously, it's just a contiguous bit of memory. So by using a vector, we get the size, begin and end, and all that stuff for free. So let's do that again. So for int I equals 0, I is less than numbers dot size, and then plus I, and now we're looping through once. Let's get this thing to shut up with the warning. And now let's do for int j equals 0, j is less than numbers dot size plus j, and so we're going to loop over the full list of numbers once, and then for every number in that list we're going to loop a second time from the beginning, and then try and add every combination of numbers until we hit 2020, and then we could just break out of the loop. Okay. So let's now just say numbers, if numbers at I plus numbers at j equals 2020. We'll say great success, and then obviously this is just going to keep looping when it finds the combination, but let's actually do numbers at I, numbers for actually numbers at j, and beauty. That's a long line, but I don't care. We can actually move it down like this. Okay, so now when it finds the two numbers that add up, it's going to tell us that we're a great success. And let's run that again. Why did it not do what it's supposed to? Oh, it's because I'm a dummy. We gotta actually call that function. Okay, so it's obviously finding the combination that it's finding it once and then it's finding it again in reverse. So yeah, we just need to break out of the loop once we find that. Okay, so let's say int num a equals 0, int num b equals 0, and then what we need to do, actually, yeah, let's do that. These will fit. And then actually let's return an unsigned integer. What did I do wrong here? Oh, nothing. It's just being slow. Okay, and then let's break. Actually, it's continue, not break. All right, and it's obviously continuing just that one loop. Okay. We don't care. So you probably also want to check if this in the second pass that these I and j aren't equal So let's do and I is not equal to j. Let's compile that. Okay, still getting that. Okay, good. Now let's set int. We'll say num a equals numbers numbers at I, num b equals numbers, or actually, forget that. Let's just, I usually don't like to do multiple returns, but I don't feel like dealing with this. So I'm just going to say unsigned int product equals 0. And then let's current product. And then once we find it, I'm just going to make a return out of the function. I don't care. We're going to say return numbers at I times numbers at j. So that's going to multiply those two numbers together. And then here, we're going to say cout the product is, and then end line. All right. Okay, it's being real slow. Okay, let's compile. This is pointless. I don't know why I did that. Okay. Yeah, that's obviously not going to work. Okay, so we found 317 plus 1703 add up to 2020. The product is 539851. So that seems about right. Let's submit that. Does it tell us if we did it right? That's the right answer. Okay, we got a gold star. Should we do part 2? Okay, no, let's have some fun with this. Okay, so this is obviously slow. Let's see if we can do it fast. Okay, so how can we do this fast? Actually, we don't need that. We'll do it differently. Okay, so we have a list of numbers. We want to see how these numbers add up, or which two numbers add up. So if we don't want to have nested loops and n squared runtime, let's think. Maybe I should have made another coffee before doing this. We're going to loop. We can maybe split the list. If we split the list in half, will that help us? We'll keep splitting it. I don't know. I'm trying to think if I can do it in like a a log_n runtime or something where we keep, you know, halving what so we're not searching the whole list every time. How do we do that? Or if we sort the list, that's another thing that might help us. I'm trying to think of things that we can do to this list, or ways we can approach the list. And, you know, what would happen if we sorted that list from, say, smallest to largest? Would that help us figure out? I mean, we still have to look at two numbers, right? And so whether or not it's sorted, like, it won't help us. We're still looping. We still have a nested loop. I almost don't even care. Thing is, if we sorted the list, then we could look, like, our first pass we're still going to go through every number, but our second pass we could speed up by, you know, having a sorted list, and then in the second pass we could look for a number that's greater than the number we have remaining. So essentially it would be like we're still going over every number, right? So let's say for int I equals 0, I is less than numbers dot size, right? So our first pass we still check that first number, but then in our second pass we don't actually check every single number because we're going through a sorted list. We could maybe say, like, let's say we have, this is just, think of this as pseudocode, but let's call it remaining, right? We start with 2020, and then, or we should probably put that in here, and then we subtract, let's say, minus numbers at I, right? So we know, you know, we'll know how much is left over, right? So if we look at this 2020 minus 12,211, then that'll give us it'll give us what number we need in order to actually find the second number. And if we have a sorted array, then we could just do like a, we could only look at the numbers. So we'll start in the middle, and then we could only look at the numbers that are greater than what we have remaining. So we can essentially do the second part in log_n runtime. What's that called again? Binary search? Yeah, I think binary search is, yeah, it's been a while since I've done these. But essentially what you do is you, like, with a binary search, you're taking the midpoint, and then you're, so because it's sorted, right? Let's say our remainder is 500. So we took 2020, subtracted our first number from it, and now we have a remainder that we need to find that second number. So instead of going through every element again, what we could do is essentially look at this list and say, okay, look at the midpoint. Is our middle number greater than or equal to or less than the number that we have remaining? And if our number is greater than this middle number, then we need to look at this half of the array, right? If our number is smaller than this middle number, then we need to look at this half of the array. So now we've essentially isolated half of the list, right? And we've narrowed down, okay, we only need to look at this portion of the list. And then you do the same thing for this half. Let's say our number is greater. Let's say our number is 56. Then we come here and we're only looking from here to here in the second pass. And not 56, let's say 72, just so we have a third pass. And then we check here, and then we look at this. Okay, is our number, is our number greater than or bigger than the middle point here? And then if our number is greater, then we keep halving the list that we're searching. So that's what a binary search is. That's one way to do it. I'm just trying to think. It's still a nested kind of search, which I don't like. Like it's going to speed it up, but it's not a very big speed up in my opinion, or maybe it is. I don't know. You're not doing a linear search on the second pass, so obviously it could be much faster. But I'm trying to think if there's a way to speed up the first pass. Okay, let's actually try something. We'll do and then remaining. So that'll give us the position of that number, and we'll say if ITR is not equal to, what am I doing? All right, is not equal to numbers dot end. Then we'll just say return numbers at I times ITR, and then do we get? Well, we compile just fine. Okay, so essentially what I've done is I'm just using the find algorithm here to find the remaining number. And let's see if this gives us the same result. And it does. I'm not sure how much faster that is. C++ is C++ find algorithm. How does that implement it? Linear and the distance between first. Okay, so that means the complexity of this algorithm is up to linear depending on the input data. So let's try binary search. I mean, we could just implement the binary search, but it's a lot better to use the standard library when you can. What are the, let's see. Let's try that. What is the return of binary search? Oh, it's just going to tell us it found that value. Okay. So that's fine. So then we can just say bool found equals, and then if found, then times remaining. So all we've done here is we check every number, and then we get the remaining, and then I'm really curious how much faster this actually is, or if it's even faster. I mean, it could be measured. I could put some like begin and end here, and then just see how much time this thing took. But essentially, we could say we loop once, and then we get the remaining number. Then we check if that number exists in there, and if that number does exist, then we just return that. And oops, why is that? True for an element, equivalent found false if otherwise. Okay, so why is it returning? Looking through all the numbers. And so we search. I'm confused. Why are we? What am I doing wrong here? Product is 0. Why is it actually returning a 0? const eval. Which contains all the elements first and last, including the element pointed by first, but not the element pointed by last. Oh, God, of course that's not going to work. We have to sort it. So there's a sort function. Numbers dot begin, numbers dot end, and let's recompile that. Okay, so that works. I'm really curious if this actually sped it up. I mean, there's probably like a more clever way to do this. Obviously, so here we're introducing the sort, but you know, if this list was substantially bigger, then you know what? Let's see. File function time. It's a good way. I'm thinking the high resolution timer with Chrono, which is exactly what they're doing. They get the start, they get the end, and then they print it out. Let's do that. Let's quickly see what the difference is. Okay, so then, yeah, we'll do it So let's get the auto fast start equals, and then we just call now on the high resolution timer. I've used this timer for, why is that? Oh. And then we'll do fast end. And then do we just subtract them? Okay. Duration cast milliseconds. Okay, so this will tell us the auto fast result. This will tell us the speed, fast result, and then we can say count, and then they're just printing it out to milliseconds. Took fast result, seconds. I'm very curious. What are you complaining about? Where's duration cast coming from? What am I doing wrong here? It's gotta be, let's look at an actual thing. Actual articles, okay. So clock doesn't work, so they're gonna tell us about the resolution. Where's the high resolution timer? There we go. Okay. Now end, and then oh, I think it's because it's that way. Is that answer? I think that's why, because whoever wrote that answer just didn't really check their work or something. So let's just see. Oh, that doesn't make any sense. When they're saying how to measure execution times for detail in the kernel library, see this and this. Okay. Time taken. They're doing it in nanoseconds. Maybe, yeah, maybe it's just so fast. Actually, I'm just gonna use the same. I'm not gonna. I was gonna do it twice and then have them both print out, but that's okay. So that did definitely. Let's get rid of some of the. Actually, who cares? So obviously, it's quite a big difference between the two. right? Here we have 90,000 nanoseconds, and here we have 2,000 nanoseconds. So that definitely made the second search a hell of a lot faster. Let's wonder. Then decrement number. How do you do that again? Normal, control A will increment the next number, control X will decrement. I think I can decrement all these numbers. Or no? How do you do that? Probably can't. Maybe you can do it like this. No, whatever. I'm guessing though, if this number, or if this doubles up, like if the number of times we're looping, I just wonder, the thing is we're using the same numbers, I want a different set of numbers, but if I run it, this is with slow, it averages out. Quite slow. And the average of fast substantial difference. Let's get rid of those numbers again. This is slow is averaging out. Sometimes maybe it's just my it's probably just the CPU frequency kind of it's not constant, right? Like the speed at which your CPU performs, it goes up and down as the workload goes up, and it's constantly being changed. But it looks like you know, it's substantially slower. And then if we do fast, we can see that, yeah, what is that? Let's say 90,000 divided, so it's a huge difference, right? 3078 divided by 91373 is, you know, that's 3% of the time the slow one took. Is that what that is? Oops. Let's do it like this. Times 100. Right? Yeah. I don't know why I had to do that. My brain's fried. But yeah, that's quite a big difference. Anyways, that was kind of interesting. Let me know if you guys have a better way of doing this. Maybe I need to get better at thinking through these while I'm on the spot, being recorded or whatever. But I'm sure there's a more clever way to solve that without even using the binary search. There might be some other trick. If I do think of something, I'll record a quick video showing how I did that, and I'll also keep the actual the time check that we have here to actually instrument this bit of code and see how quickly it executed. But anyways, give me your thoughts down in the comments. Let me know what you think, and I hope you found that interesting. Thanks for watching.